Thank you very much for the kind invitation. I'm going to spend 20 minutes talking to you about buildings and their future. Um, we're going to really explore what's changing in the future of buildings, how IoT, sensors, and AI are starting to have a pretty serious impact just at the right time. Now, I just want to explain Novacene, the name, for a couple of minutes. So, um, obviously, we saw a massive change in the industrialization back in the 17th century. What we're seeing right now with IoT, with AI and networks is significantly much bigger, and it's needed like never before. What we're seeing, the challenges that we face, AI is the perfect tool for that, and that's been called by a couple of academics the Novacene period, where AI is starting to control our environment. Now, I want to talk to you about that environment being buildings. What does AI in buildings mean? Are we talking about a prison type environment where the building is controlling every aspect of our lives, locking us in rooms, or are we talking about something a bit more beneficial, mutually beneficial? So, what you can't really talk about buildings and AI without understanding context, and context is about, in the simplest of terms, do you care about this building? Do you care about the room? A good example would be a nursery within somebody's home. You care. It's the right temperature. Does it have air quality? You've got sensors listening to the child, and that's a room that you care about. You love. But most rooms and buildings that we spend our time in are just nobody cares. The big challenge with buildings is not about technology. It's somebody else's problem. We're often seeing buildings leaving heating systems on, and that's what I want to talk about a little bit more. So context. Once you do understand the problem and you understand that there is an issue, temperature's too high, what can you do about it? And that's the control element. It's all very good understanding that you have a CO2 issue. There's nothing you can do about it. It's just a problem that you've brought to often to the board. And the third piece I want to talk about is why. Why should I care? Now, addressing why I should care. Now, the current state of buildings right now, and when people think about smart buildings and IoT, you often think of a glass skyscraper in a central city, and that often has a BMS, normally very expensive, but that only represents a very small percentage of buildings, often referred to as trophy buildings. So the other percentage of buildings, they're completely dumb. They're zombie buildings. And the reason that hasn't been a problem until recently and until now is just costs. We've seen buildings such as schools go from paying £38,000 a year to £170,000, and they don't have the money to solve that issue. So there's a real drive to reduce consumption. And the benefit to that is we're reducing the amount of gas needed to heat a space. When we talk about energy, most heating energy in Europe is from gas. And just by removing a small percentage of that, normally 20 to 35% is very, very easy to attain. That across the public sector, just within the UK, is about 5 to 7% of our greenhouse gas emissions. And then the last point here is it's very important for companies to report their ESG. We're still trying to define what ESG really means, but being able to show that your property estate is starting to reduce consumption, is giving you savings that you can redeploy. And within Europe, there is a need, a requirement to, to be able to control buildings much better. Now, we all know what's at stake. Whether you believe that it's caused by humans, we're seeing huge amounts of CO2 going into the atmosphere, and that's creating a blanket around the planet, which is warming up significantly. And the challenge is not just about reducing the consumption, reducing the gas that's being put into the atmosphere. It's actually removing the CO2 that's already up there. And that technology doesn't really exist. It needs to, and we need to remove it at an incredible rate, 17 gigatons per year. And just to put that in perspective, you would need a forest the size of Africa, the continent of Africa, to be removing that. And this is mature trees. So the challenge is huge, but it's solvable, and it's solvable with AI. So 40% of greenhouse gases from buildings, big problem. Now, what's good about this is the technology is working. IoT, in the form of LoRaWAN, networks, low-cost sensors using energy harvesting rather than just using batteries. That is there, it's working. The capital is now becoming available. Large investment houses will not invest into physical assets, properties, unless you have an ESG scenario. And we're also seeing from building owners not just the cost benefits of reducing, but they are driving this because it's the right thing to do. But we still have a massive issue with 91% of the buildings. So this is a very quick example where we took this technology, we created a digital twin in all the schools in a part of Scotland, 150 schools, and we were able to do that within a month. And that's digital twin, installing about 7,500 sensors, and starting to look at that data. And what that data told us very quickly was, first of all, we did this for COVID, which classrooms had higher CO2 levels. But because we're using sensors, we can start to look at, why is the boiler system coming on at 6 o'clock? Why is certain rooms being overheated? Children generate heat. So we started to see some rooms being way too warm. CO2 levels at a point where the children, the pupils, found it very difficult to concentrate. It was the equivalent of them having a pint of beer before going to school. Their cognitive performance is impaired. So we started to show this information, but the challenge became, well, look, we know we have this problem. What can we do? We don't have the budgets. Energy costs have gone up. So we had to look at more creative ways to help them reduce money so they can start to fix fundamental issues. Now, going back to context, the reason this is so important is we have a sensor, we can stick a sensor anywhere. Unless that sensor knows that it's in a zone context, it's in a classroom, and that classroom is occupied. The site that it belongs to is a school in Scotland, and Scotland at the moment is a bit cold, it's a bit rainy, whatever that is. And we're taking the existing information when the site was built, what its heat loss factors are. All of that context is determining how we treat the data from the sensor. Now, all very straightforward so far, but very few systems, particularly for AI, is understanding context. So moving that forward, what we are doing is taking that data and crunching it through what we're calling, everybody's calling it AI system. It's predictive analytics, and we're starting to find certain insights that we can control. So maths and English, because you have to study it, often has the largest classes, which has much higher CO2. they don't need as much heat. So we can start to tweak the radiator valves. We can start to tell the boiler remotely when to come on, when to go off. Certain classroom isn't being used. Um, there's a coronation one day, recently, but a lot of the schools carried on heating just by being able to switch those schools off is significant savings. So there is so much data around a really simple building that you need to constantly be monitoring and responding to. So we're not talking about smart buildings, we're talking about reactive, responsive buildings. And that can only happen with context. This is another project we've done. And as you can see here, again, still sticking with schools, just switching the radiators off, the boiler system, gas boiler system off on weekends. Not off completely. We still need to keep the building at the right temperature. We're seeing a £70,000 saving. The cost of doing this, of putting sensing, putting an AI tool in, is paid back within a couple of months, within 3 months. So the benefits of making buildings smarter, reducing consumption, creating a better environment for the people using them, it isn't one about cost. The bit I won't go into too much here then is once you can start to manage the building and you can start to migrate that away from gas consumption, it needs electrical supplies. Most buildings in the UK and Europe don't have a big enough electrical supply to run the heat pumps, to create an alternative to the heating. So it means we need solar panels, we need batteries. You just don't have a grid capacity in many countries to manage that. So to do that, we need to start looking at much more creative ways on funding. And what we're showing here on a typical project, just by reducing that consumption down, which is the green, you're preventing the use of gas. That saving can be used to go and get funding to add the additional bits of equipment, so solar panels, heat pumps, etc. So we can create the savings. We can use those savings to go and get further funding to take the buildings off the gas supply and put them onto an electrical supply. In the future, we'll need a lot more electricity, so just cutting gas isn't the right solution. I'm getting close to time, so I'm going to try and finish off very, very soon. What we're talking about at the moment, if anybody's watched the latest NVIDIA presentation from the CEO talking about the future of AI, we're talking about physical AI. We're talking about robots. But if you think about a building as a robot, a bit weird because we're living inside them, but these buildings now need to start responding to us when people are arriving. Is the air quality good enough? Is the lighting levels good enough for the task that you're performing? And the technology is there to do that. The savings are there, but we need to go much further beyond what we're currently deploying in the form of BMS. Like I mentioned earlier with BMS, most BMS systems in big buildings, in trophy buildings during COVID didn't save 70% of its energy consumption when there's nobody in there. People weren't able to go there. So you'd expect it to have reduced the consumption. It didn't happen. The smartest systems we have out there right now are pretty dumb, and everything else is a zombie building. So the technology exists, but we need to start treating buildings as if they're a robot. And pretty much nearly the last slide, the way we are reacting and responding to our buildings isn't going to be through very beautiful graphics anymore. It's going to be through the likes of a ChatGPT. Hey, by the way, I see that you haven't come in today. Everything okay? Do you want me to switch the building off? So you're going to be talking to your buildings a lot more rather than just using interfaces to find out what's going on. Too much emphasis, too much talk about actionable intelligence. Let's find some problems, let's show them to you, and nothing gets done. What we've got to do is start doing actionable outcomes where the system itself is doing that for you and reporting back. And I'm going to finish here because I think I'm running out of time. Um, this is a project we've done with Blenheim Palace. Now, great logo, wonderful project. The reason I'm showing you this is a 350-year-old building. Old boiler systems. We can't change the lights. So the glazing to triple glazing for the energy reduction. And they're still saving money. They're still massively reducing consumption. They're using sensors to understand how their beehives, how their butterfly, believe it or not, butterfly houses are performing. So this is not technology that needs to be added to beautiful glass buildings in central cities. It can be used anywhere. So that hopefully takes me to the end of my time.
So what steps do you think the industry should take to address these issues effectively?
Yeah, I mean, with absolutely super important. Now, what we're doing from a technical side, the sensor data that we're receiving from buildings it doesn't tell you anything. It's a random device ID giving you some data. It's only when you actually merge that with the context of the data that it starts to make sense. Now, I'll give you a really not a pretty example. We did a sensor project in a hospital, monitoring the bathroom use, the water use, all sorts. And what we thought we had was an issue with sensors, and it turns out that men don't wash their hands. Most people are probably, agreeing and nodding. And very, very simply, we had to start with, we don't understand who those people are. We just knew they were the male staff weren't using weren't washing as often. So you're always going to be able to find data about the building's use. If the CEO's office is something's happened to a company and we see that the lights are on, there's high CO2, we know something's going on within that building. So you're always going to be able to derive that data. Protecting the AI system, making sure the AI that you're using is your own, it's on your own hardware, you're not using something more open, is super important. Because we can find so many things about certain buildings. What we don't understand and what we don't know is the individual. We don't know it's Mrs. Goggins' classroom and little Dave Smith is one of the pupils. Spinning that back round, however, where we've used sensors a long time ago where it had a display on it, little Johnny was going home telling his mum that the sensor is red and flashing and he thinks it's an air quality sensor. So suddenly there was, hundreds of mums and dads phoning up saying, look, we shouldn't be sending our children to school because you have CO2 issues. So how you share information is really important. But the security of that, who gets access to that data when you want to share it with the user, of course, super important. But the insights we're finding with the amount of data we have, like I say, we're finding certain classrooms or have higher CO2 based on what they're teaching. So there's still a massive issue that needs to be solved. But from the security side of the data that we're pulling all the way through, it's as tight as you're going to get.
I would respond, but we've had a flood of questions, and I still have one more of my own. Last year, there was some in the industry calling on the government to introduce a smart building rating, which was designed to complement like a reformed EPC. I want to know your thoughts on that and whether there needs to be more regulation to encourage the uptake of smart tech.
Yeah, absolutely. I think when you really just distill everything down, from the performance side of it, it's pretty much kilowatt hours per meter squared per year. Now, obviously, you expect some buildings like pubs to have a much higher consumption than, say, a school. And what we are seeing is there is a massive divide between, and not always on the positive side, by the way, on some offices versus, say, a school. And there isn't a really good standard here. There isn't real science behind why these things are happening. And one of the ones I tease people about quite often is why, when a building is not in use, you take it down to 10 degrees, 12 degrees. Other, why 10? Why
Yeah.
not 7? Is that not about? So there's just not the standards around. And then some of these smart building standards that we do see, they're not taking into account, and they're competitive. I mean, you've got well, you've got research, you've got um, Fitwell, all giving you a slightly different example of what good CO2 should be. But it really depends on how that space is being used. You know, good
Yeah.
CO2 using according to Fitwell is different to a classroom. You know, to what it would be within within an office. So the context again is super important. And again, it needs to be dynamic. I mean, over in the US, people prefer the temperature to be 24 degrees. Over here, we'd be cooking.
Yeah.
So it's all about where the building is, what it's being used for, what's in that space. Taking Blenheim, for example, if you've got an oil painting in that room, you've got to treat that space differently. So it's a very fluid thing. And the simplest way for us is to take it down to kilowatt hours per meter squared per year.
Yeah. I guess tailored approaches is what you really need in this context. Otherwise, one size does not fit all.
No.
Speaking of one size doesn't fit all, as smart buildings and smart tech become increasingly integrated and ubiquitous, what challenges in terms of interoperability do you think you might see, and how do we address those?
I think again, I've been in the tech industry for years. I think that we will always have that issue. We always sort of have had that issue. Um, Somebody's standard is always better than somebody else's. I've never met a techie that would approve the database we use on our back end. There's always a better one. However, that has changed a lot. I mean, particularly with, for example, we use a lot of sensors using LoRaWAN, and because it's an open sort of it's an open standard. It's an open. We're seeing lots of new entrants coming in, building new technology, better sensors, lower cost sensors. So we don't have that walled garden issue where we've seen with other sensor manufacturers. So getting data out, understanding data is not really a problem nowadays. Pick a standard, follow it. Whether you use a Microsoft database or something on AWS, they're not really the challenges. The challenge we're seeing is once you have that data, how do you share that with other people? How do you get other people giving you the insights? But yeah, there's enough open standards out there at the moment.
And you touched at the end of your session on AI, and this person in the audience said, "Do you think AI will have the biggest impact on the future of smart buildings? And how do
Oh,
you think
absolutely.
potential new government AI regulations will actually impact the industry?"
I mean, regulations do exist. I mean, I've noticed a lot of AI experts popping up all the time now. Most people, most companies we work with, we really struggle to even get floor plans of a building that are in a recognized format. It's normally an image in a PDF. So, it's very hard to get data in a proper format. So making sure it's in a place it's available that can be used by any other system is crucial. Turning that into a digital twin, understanding where the walls are, what they're made of. Do you need to go down to doorknob and skirting board level? Probably not. The AI side of this, what we're seeing, systems that we were designing 2 years ago about creating complex rules engines for context have all changed. Now you can almost explain that to a general AI, and it works out and gives you the answer. We're starting to interact with our buildings very differently, and the reason that we've not been able to digitize and connect to 91% of the buildings is it's been too expensive. We've used existing BMS type tools. And AI is changing that. You know,
Yeah.
you need to be constantly tweaking the building based on what's going on around it, how many people are entering, what the weather's going to be like tomorrow. Is greener electricity available on the grid? Let's use that to power up my batteries. All of that is far too complex for a person to deal with, and too expensive. So yeah, AI all the way.
That's more than a full-time job in order to sit there and try to analyze all that data and make actions on it. So yeah, definitely need the use of AI on that one. How do you think the balance between automated systems and user control will develop, particularly in terms of personalizing environments to suit individual preferences/needs?
Um, Trying to explain this. I mean, again, I've been in the industry for a while, and one of the most interesting bits of data I found once was when you create a brand new BMS, often millions of pounds, we were monitoring the modem that was people interacting with the building.
Yeah.
And so you can go on, you can tweak it, you can make these changes, you can look at all this, these amazing stats about the building. What we found is people were only logging in for the first 6 weeks. Um, After that, very few people log in to tweak and change the building. Sometimes with there's a crisis, they'll log in. And what that's telling you is once you've delivered it, nobody really cares. Nobody's
Yeah.
making those changes. Like I say, during COVID, these buildings, people weren't logging in and putting these buildings into a hibernation mode. So it doesn't exist right now. The systems are there, the control technology is there, but nobody's doing anything with it. We need to get AI behind this to start making those changes. And it's the only way we can go from, taking that across all the buildings on the planet right now. That's an easy 30% saving. And
Yeah.
that from gas in the gas world is a huge CO2 emissions saving. So yeah, all AI.
Well, if no one signed in during COVID, could you imagine the amount we could save if everyone has?
Exactly. Exactly.
Um, Given that development teams often work in silo, how can we ensure effective collaboration and integration of various smart technologies in building projects to create cohesive and seamless smart environments? And that's the last audience question, I believe.
So again, going back to I think what you were saying there about integration and using open standards with data is very important. I mean, even now, we work on developing technologies. We've got front end, back end people. We've got customers. They want to pull that into Power BI or whatever. So making sure that you're starting with an open API system is absolutely crucial. Making sure that you're dealing with data that can scale, whether that's a timescale DB type approach or whatever, and that data can be used in other systems. So we would start everything through that API approach. Then, if a customer needs a new front end or a new report or dashboard, you have a different team, sometimes in isolation, just developing that from the data. A lot of the work we do, it looks beautiful, nice dashboards, 3D. Customers want it in Power BI. So they just want a well-documented API to go, right, let me take that data and understand what's going on. So yeah, without a shadow of a doubt, API all the way.
I as I said, that was the last question. We had two more flood in, and I know we're running out of time. We got 2 minutes until the next session. But real quickly, do you think we have a gap in skills/smart tech professionals?
Yeah, we do. We absolutely do. And I think we also have a big challenge around a lot of tech companies have come into the industry seeing that buildings have a problem. Very few people understand the problem.
Yeah.
The most valuable people out there right now are the people that understand the issue intimately, how buildings work, or their particular building. That is going to be very easy to now convert into some kind of machine learning AI. That person with AI, with something like a chat GPT, becomes invaluable to this industry. But yeah, it's for me, it's always finding the person who understands the problem that exists. I mean, we go into schools and I go and find the caretaker. The caretaker tells us what the problems is, how they solve that. The technology piece is relatively easy.
I think
So
the whole
yeah, I would
engineering,
focus on the problem.
yeah, I think the whole engineering services industry have had an issue with skills, and it's probably something that the government, whoever the next government's going to be, needs to look more deeply into fixing. We did have one more question, but we have run out of time. So thank you for those answers, and thank you for the presentation, Bill. It is greatly appreciated.